Children, now we'll be doing a very common proof of our chapter work for energy. That is, prove that for a freely falling body, total energy remains conserved. Over here, total energy means we are meaning sum of potential energy plus kinetic energy. We have to prove that it will remain conserved. So let us just discuss this proof, and it is quite a popular proof that has been taught over the years. That is a very important proof. So first of all, let me consider a body like this, which is at a, say for example, height h from the ground. So this is our ground. Okay. So this is our ground. So this body is at a height h from the ground. Right. So this is our height h. So this is our ground, and we can say over here the height over here is h. Now what we are doing? We are dropping this ball from this particular position. So the particular ball will fall from here, and it will be just moving from here to there like this. So that means what one you can say that if you drop the ball from here, gradually the ball will be just moving and will strike the ground. So this may be one situation. That is one of the important points or two important points of this journey. Suppose the mass is m and mass is n, and I consider this topmost point to be A, and the lowermost point when it hits the ground to be suppose B. Now one thing we have to understand that when the ball was moving from the highest point to the lowest point, initially the velocity of the body was 0. And after that, it strikes the body with the maximum velocity, it strikes the ground. So naturally, I have taken two extreme points, one the highest point at A and the other the lowest point at B. I consider another point somewhere over here, a point, suppose any point at a point P, that is over here, and let the point P be at a height of x from the ground. Am I clear to everybody? Let the point P is at a height x from the ground. So what we have to prove, children? We have to prove that at this point A, at this point P, and at this point B, the sum of potential energy and the kinetic energy will be conserved. I hope I am clear to you. The sum of potential energy, that is sum of potential energy and kinetic energy, will be remaining conserved in these 3 points. So that we have to actually. So how to go start? So this is very important proof, children. So this is quite a common proof that we normally do. So let me just move along with the. So first of all, over here, let me consider the point A over here. So at A, now listen, once the body is dropped. So since the body is dropped, so therefore what can I say? The body is dropped means its initial velocity is 0, u equal to 0 over here. So therefore at A, kinetic energy is equal to how much? Kinetic energy therefore will be equal to half mu square, that is equal to 0. Now at B, then what shall be the potential energy? It is at the maximum height over here from the ground, from where the body is dropped. So potential energy is equal to mgh. Hence, if I just add up this, so the total energy shall be equal to 0 plus mgh, so that is equal to mg. So total energy is equal to therefore children mgh. I hope I am clear to everybody, children. So the total energy over here is mgh. So that is very important. So this is the first case. Now at the second case, I consider the point B because I want to take the two extremes first. So at B, when the body has reached the ground, you have to find out that what is the velocity attained. So simple equation of motion I'll use, children. V square equals to U square plus twice AS. Children, here U equals to 0, A equals to G. Why? Because the body is falling due to the with the acceleration due to gravity. And S is equals to H. So combine on writing this over here, instead of U I put 0, instead of A I put G, instead of S I put H. So I'll get V square is equals to 2GH. So therefore, what can I write? Kinetic energy at B is equals to half mv square. And what is the value of V square we have got at B? That is 2GH. If I put it over here, so that becomes half m into twice GH. So therefore, kinetic energy at B is equals to therefore mgh. So this is your kinetic energy at. Now, potential energy on the ground, what will be? Because on the ground we have taken as our line of reference. So height is basically 0. Therefore, potential energy is equal to 0. So therefore, total energy will be equal to kinetic energy plus potential energy. That is equals to mg. So total energy will be equal to therefore mg. So you can see, children, this is our second case. That is, you can see over here, at A it was mgh, at B is equals to total energy equals to mgh only. So that means in both the cases, the total energy remains the same. Now I move on to the next part, which is a very, very interesting part. That is point B. So I'll just move on to the next page. And what I will do, I'll try to draw it once again for you so that you can understand it. So over here, I have considered this to be our height. The original height was actually h, and children, this is our ground, which I have already considered this to be our ground. So now, you have seen that this is ground, and you can see one thing, that this particular ball or this particular body is at a distance of how much? I have taken, this is m, this is mass of the body as m, I took it earlier also, and originally this was at a height h, now it is at a height x from the ground. So that means it has reached going from A to P. This is at a height x and this is height h from where it was from. So that means if I ask you now that how much is the distance covered? So how much is the distance covered? The distance covered is equal to h minus x. So this is the distance. So distance covered is h minus x. Initial equals to 0. So what can I say? What is the velocity at P? If I consider this to be suppose velocity at P to be suppose v1, this is the velocity of the body at P. So I will use the formula v1 square will be u square plus twice a s. Now how much is the s it has covered? It has covered a distance of h minus x. And initial speed was how much of the body? Because it was dropped. So u was equals to 0. So I can write v square equals to 0 plus twice. Instead of a, I shall put what, children? I shall put g. So 2g into h minus x. So children, you get v square is equal to 2g into h minus x. So kinetic energy at P will be therefore equal to half m v1 square. So that will be equal to half m into 2g into h minus. So 2 and 2 gone better. So kinetic energy at P is equal to therefore you get mg h minus x. This equation will be again a very, very important equation. Why, children? Because I'll be just doing something else also where I will be taking the help of this. So let me just highlight it. So this is kinetic energy is equal to how much, children? I've already told you that kinetic energy over here is equal to mg at P is mg h minus. So this is very, very important. So let it be my equation number 3. So now the body is over here, where? At point P, and it is at a distance how much from the ground? It is at a distance x from the ground. So child, potential energy will be equal to mg, and height is x, so it will be mgx. So you got potential energy equal to mgx, and kinetic energy is equals to how much beta? Kinetic energy is equals to, therefore you got, very, very important, kinetic energy we got mg h minus. So children, what I do, this is your the potential energy mgx. I hope everybody has understood this. Now, in order to find out the total energy, what should I do? In order to find out the total energy, we should add up this. So our total energy will be equals to how much then? Our total energy will be equals to the potential energy plus kinetic energy. This one plus this one. So this will be equals to how much? This will be equals to mgx plus mgh minus mgx, because I have multiplied this mg with h and mg with x. So what shall I get? If I just cancel this, mgx just cancel. So total energy you are getting as mg. So very, very important, children, you saw that in all the three cases, total energy is mg h at P, mg h at B, and mg h at A. So this is total energy at A, this is total energy at B, so total energy at P. All the three cases, the total energy remains same. Hence, we can say that energy is conserved. Hence, energy is conserved. So you can see, children, in all the three cases, energy is conserved. Now, children, if I want to plot the graph in a freely boiling body, if I want to plot the graph to show you the variation of the three energies with the distance from the ground. So what shall I get? The three energies from the over here. So what can I tell over here? So this is our potential energy. Potential energy equals, we have already seen x. Kinetic energy we have seen mg h minus x with respect to the ground. So this is my energy axis, and this is the distance from the ground. Distance from ground. And that I have taken as what? That I have taken as x. And total energy you have already seen, that is always conserved, that is equals to mgh. So if I want to plot the graph now, how to plot it? So just let me do it for you over here. So let me just move into the next page. Over here you can see, children, see, let me just draw the graph so that you can understand how the graph can be drawn. So I take these columns to make you understand how this will vary. So first of all, let me take x equals to 0. Rather, let me take this way, that will be better for you. So let me draw a line over here. So suppose I take it over here at x equals to 0. So this is our variation of x. This is your potential energy. This is your kinetic energy, and this is your total energy. Okay. So over here, if I just take this to be the x, so how will it look like? So over here, this is our x, and what is x? I've already told you, distance from the ground. X is the distance of the body from the ground. This I have already told you. So now over here you can see, suppose x over here is say 0. What will be the value of potential energy? Because potential energy formula is mgh. Kinetic energy is how much? Kinetic energy is equals to mgh minus x. And total energy over here is gh. Now you can see, when the body is at x equal to 0, at that time potential energy is 0. Kinetic energy will be maximum because x equal to 0 means it is on the ground. And total energy is also mgh, right? Because instead of x, I'll put the value of h. Now suppose the body is at a height h by 2. What shall be the potential energy? Instead of x, if you put h by 2, so you'll be getting mg h upon 2. And instead of this, if you put over here, so this will be mg h minus h by 2. So that will be once again mg h by 2. You can see over here, potential energy and kinetic energy is same. But one thing you can see, the total energy is once again mgh. So this is your this part. Lastly, when x is at the maximum height, because we have taken maximum height to be suppose h. So this is your maximum height. Okay. When it is at maximum height, potential energy is mgh. Kinetic energy at maximum height, if I put x equals to h over here, kinetic energy 0, total energy remains to be mgh. So children, you can see, I can just over here, I can write that potential energy in this case increases, kinetic energy decreases, and total energy remains the same. Am I clear to everyone? So now if I try to plot the graph over here, first of all, suppose I take this as x equal to 0 over here, I take x equals to h by 2 over here, and at same distance I take x equals to h. And over here I take, suppose energy is equals to mgh upon 2 over here, and maximum energy is mgh. Now if I try to plot the graph over here, you can see this is equals to, when x equals to h by 2, at that time this is equals to how much? The energy is equals to mgh. So I am drawing the potential energy graph first. So over here at x equals to h by 2, potential energy is h by 2. At x equals to 0, potential energy was equal to how much? Potential energy was 2. So this will be my first point, right? This will be my first point. This will be my second point. And the third point, that means when x equals h, so potential energy was mg. So I plot my second point over here. So third point is this. This is your third point. Now I draw the graph. So your graph will look something in the straight line. So this is the graph of what? This is the graph of your potential energy, variation of potential energy with x. So this is the first graph. Now I move on to the next one, kinetic energy. So kinetic energy, you have seen that when x is 0, kinetic energy is mg. When x is h by 2, kinetic energy is mgh by 2. When x is h, kinetic energy. So I'll plot similarly over here. So when x equal to 0, kinetic energy is maximum. So let me draw with a different color. The blue color is the kinetic energy. When x equals to h by 2, kinetic energy is equal to 0. When x equals to h, kinetic energy is 0. So now I can draw the graph over here. So this will be your kinetic energy. So this will be your kinetic energy. And every point you have seen, the total energy remains conserved. So total energy remains conserved. So that means the total energy graph will be, so this will be the total. So this is your potential energy, this is your kinetic energy, and this is your total. So this is the graph which is showing the variation of all the three energies with the distance from the ground. So we have proved today two things, or we have done two things over here, covered two things. One, energy is conserved, and the variation of energy with distance